Hello and welcome back to the Mongodb Twitch stream. Today I am with Sheeri Cabral, who's going to be leading this particular stream, and we're going to be talking about data modeling, especially if you're coming from the relational database background, because Sheeri, you used to be a DBA, correct?
Yeah, I was a MySQL DBA for almost 20 years. So I have those normalization and tables and all rows and everything stuck in my brain forever.
Awesome. Then if you are coming from that audience on the stream, then this is definitely going to be valuable. But before we jump into that material, I want to go over some logistic stuff. So we are live. This is a live Twitch stream. It will be later available on demand on YouTube. But while we're live, please engage with us in the chat. I will be actively monitoring the chat. If you have a question for Sheeri, I'll stop her, and we'll get that question addressed. Also, if there's any kind of audio or video problems, stop me for that too. If there's any kind of issue, I want to be able to correct it to make this as great of an experience as we can make it. Is there any kind of plugs that you want to give before we start, Sheeri?
Wow, I didn't think about plugs. The Ofish app is an open source application that we developed in conjunction with a not for profit called WildAid to help keep all our waters clean. And we're going to do a brief demo of the app so you'll be able to see it. But because it's open source, we have this opportunity coming up for Hacktoberfest if folks want to actually develop on it. That's going to be github.com/wildaid is where the repos are. Um,
Sweet.
and that's really the only plug I have.
Works for me. All right, so I'm going to show your screen, which is currently
Great.
on a slide deck. So I'll let you
That's
take it
right.
away.
All righty. Hopefully everyone's doing well. And, I don't know if folks have been using relational modeling or how long you guys have been using document modeling. So feel free if I'm going too fast or too slow, say it in the chat, and Nick will convey that message to me. So here we go. Um, I wanted to talk today about document modeling in MongoDB using the Ofish application as an example. So, real world application, how did we decide to come up with the schema that we did? So, the goal of data modeling, what's the goal of data modeling? Well, the goal of data modeling is to come up with a schema that's going to work best with your application. You're going to want it to be as simple as possible, right? When we normalize tables, we end up having hundreds of tables, and it's kind of frustrating. But it's not really having to keep track of all those tables. It's a problem. It's the speed when you have to join all those tables, look through them. You do a 5-table join. If everything was in the same table in SQL, it would just be easier. You could just, get the rows you need. And with MongoDB, document models lets you be flexible, and there are many ways to do your schema, so you can kind of have that. Now, you want to do this. The reason that you do data modeling is you want to do all this before you're really heavily into writing your app, because when you change the model, then you're going to have to change the code as well. One of the great things about MongoDB is that you can add and remove fields with very little, problems, no downtime, that kind of thing. And with SQL, it can be a little harder. And so, both with SQL and NoSQL or document modeling, you're going to want to, you know, get it right the first time, or maybe not 100% right, but you're going to get it really close the first time because you don't have to spend time rewriting stuff. Because you're going to have to do that anyway because your app is going to change, right? So, how is the document model different from the relational model? Well, there's actually 5 different ways. Don't be overwhelmed; they're not that crazy and involved. First is that fields are key value pairs. Now, you could think of the relational table as a key value pair, that the key is the column and the row is the row value. But with MongoDB, it goes a little farther. We have polymorphism. So, this is a fancy word for your schema can be different. You can have one document that has one field, but another document doesn't have that field. And instead of just having a null value in the row, the key value pair just doesn't exist. This is very powerful when you think of something like attributes of a product. Like, let's say you have a store, an online store, and you're selling a bunch of things. Maybe you're selling T-shirts, and your T-shirts have, colors and sizes. But then you're also selling, magazines, which have a publication house, and it has an editor in chief, and it has, a date on it. Which edition is it? Is it the September 2020 edition, that kind of thing. And with MongoDB, you don't have to have like, another attributes joining table to do all that stuff. You can just do it easily in your existing collection. With the key value pairs, the value doesn't have to be just text or a number or a date. It can be a document itself. And I'll show an example, in a bit. And it can also be an array. So you're not just limited to like one small piece of text in the value, which is, hugely powerful. The document model itself is going to look like JSON. So all you JSON folks are going to see things that look really familiar, although it's internally stored as BSON because that is faster to store and retrieve.
But
So
from
what is
the
the
usage
methodology?
perspective,
Oh,
you only have to worry about JSON, right? For people who might be new.
yeah, yeah. You don't have to worry about it. It stores it internally as BSON, and you don't have to worry about it. You just look at it, and it's going to look like JSON. We'll have some examples too. So if something doesn't look right, yell. Are there
Sure.
any other questions? I don't know if that was a Nick question or an
That
audience
was
question.
one of those stupid Nick questions that you'll get a lot of today.
Well, they're not dumb. It was a good question. So what is the methodology, right? In a relational schema, you normalize either through first normal form and second normal form and third normal form. We don't really have a mathematical formula. That is literally math that's done there. There's relational calculus, relational algebra. You can go up and read papers by E.F. Codd on it if you really want to. Um, I think Animal Crossing is probably more fun these days than that, but everyone they didn't have Animal Crossing when I was studying the stuff. So with both relational modeling and document modeling, you have the same end goal, right? The process is just different. So, with relational modeling, you normalize, and then you probably do normalize because you don't want all those, tables around. You want it to be faster. And, I don't think I ever used a completely third normal form database. It was always, when I was doing stuff, it was always unless it's a super simple thing, but it was always, you know, like 100 tables with all these different like foreign keys and references to each other. Um, in document modeling, there isn't any particular like formula, but the usage determines the model. And there's going to be much more detail later, but here are the basics. The basics are figure out your workload. You're going to want to list what's going on. So, what are the most important queries? What are the most frequent queries? You're going to want to know like the size and how critical they are. How critical are those posts in your blog app, right? Um, so identifying and modeling the relationship, that's step two. Step one is actually it's a lot longer than you think it is. Um, and so if you end up spending a lot of time on that, don't worry about that. We're not going to like go for 3 hours on this Twitch stream. Although that might
So,
not be a bad way to do Friday for me.
so I have
Although if you have any
one of those
Australia,
Nick
yeah,
questions.
yeah,
So
great.
you're recommending as part of the development process that you figure out what queries you want before you identify the model?
So it's not like figure out the actual like code query that you would write, but just kind of the description of the query. Like we need to retrieve, a blog post based on how current it is, right? You go to a website and you have blog posts and
Sure.
you want to see the most recent ones first, right? So we're going to do that. And that's going to be a very frequent one because people go to the homepage a lot. And maybe like a little, and that has to be like fast because we don't want to lose people's attention. Whereas if someone is searching for a specific author, right, that's going to happen
Yeah.
less frequently. And so maybe it doesn't have to be as fast because they're like invested in Nick's blog post. So like I've typed in Nick and I want Nick's blog post, so I'm willing to wait a little longer for that. Um, and it's not always that the most frequent queries are also the most important ones. That was just happened to be that in that example. That is a great question. Um, I'm going to wait a little bit in case there are any others before I move on.
No, that was my question.
Sweet. So after we describe the workload, we identify and model the relationships. I'm actually going to give you an example of what it looks like in an entity relationship diagram that you might draw if you were kind of an SQL person, and then we work through that. And when I say model the relationships, we're talking about like one-to-one, one-to-many, or many-to-one, and I will explain why I specify that, even though you might be like, well, they're the same, and many-to-many. And so you're going to basically choose like, do you put them all in the same document? right? Or we don't have tables and rows, we have collections and documents. So a table in SQL, the kind of equivalent idea is a collection, which is a collection of documents. So a document is kind of like a row. But when you start to see it, it'll be like, that looks like a lot more than a row, which is the cool part. So when I say embed or link, I mean embedding it in a document or linking it by having more than one collection. And then you apply some patterns, and we'll talk about what those patterns are. They're kind of, they're not like SQL patterns or anything like that. They're MongoDB patterns. So with that, let me know if there's any questions. I'm going to go into a demo of the app if there are no questions.
No, we're just chatting about random stuff in the chat here. We got Taylor C. Johnson is interested in this stuff because he's getting prepped up for a release tonight. We got you old maid that showed up in the chat. So Karen.
Great. Yep. All right. So here's the demo. This is our mobile app on, oops, this happens to be on iOS. I just locked my screen.
Ooh,
Can you see my screen again on
we
the
can.
iOS?
Yes.
Perfect. Awesome. So here we are in the Galapagos Island, and what this app is used, it's used by officers. Here it would be in the Ecuadorian Galapagos kind of navy, you could say. And so here we are in the Galapagos Island. So we've spotted a vessel, and we want to go board it. So we're going to board the vessel. You can see that we have some, recently boarded ones. We're just going to add a new vessel, but you can see that we've actually synchronized some data here. This is actually pretty cool. We're using Realm here. So Realm Sync, which is, I think we announced it a couple months ago, but it's pretty good. What it does is it enables a mobile developer to connect with an Atlas database. So you connect the Realm database on the mobile device, whether it's Android or iOS, and it connects to an Atlas database in the back end, and it seamlessly synchronizes from one to another, including in offline mode, which is super important because I'm going to cancel this, when you're here, or out here, you may not have any signal. You may not have Wi-Fi, you might not have cell signal, you might have satellite. We don't know. And the cool part is that it's not like when you text someone and it didn't go through, and it's like, oh, it didn't go through. Do you want to try again? With Realm, it just happens. And so you'll see here, we can submit something, and it just is great, boarding submitted. And maybe it got to the database yet, maybe it didn't, but it will sync there. And one of the cool parts is that there's like 3 lines of code to write. It's not, you don't have to spend, pages and pages and lines of thousands of lines of code writing all this infrastructure. Realm just does it for you. So
And
that's pretty cool.
and you and Karen actually did a stream on this a month or so ago, going into the finer details of this application, right?
Yeah, we sure did. Yeah.
So I forgot the
Going into
name of
finer
that.
details specifically about Realm.
Yeah,
I don't know.
it's on
Maybe
the
Karen
YouTube
can.
channel.
It is. It is. Karen might be able to dig that up for us.
Yes.
So here we have, we were just going to board a new vessel. Not that it really matters. So here we are. Here's the time and place. Here's where we are. We go to the vessel. And I just wanted to show, like, here's the vessel name. And we're talking here about like just text fields, right? And the permit number. I mean, I could write strings in there. The home port. Let's just call it Boston. And then this is the flag state. Flag state just means like the nationality that the boat is registered to. Now you can see here we have this list of all the countries, and iPhone gives us these nice flags for all these things, which is pretty cool.
Yep.
Android doesn't have that, which has made me sad.
We have a question coming in.
But
So this
yeah,
is
what's the
from
question?
Geminis, I believe is maybe how you pronounce that name. There's always this contention between writing and reading, so querying, when it comes to persistent data. Am I supposed to be more focused on one or the other when it comes to NoSQL?
That's a good question. I mean, it's less about, a lot of people like to say things like, what should you use, MongoDB for? What should you use NoSQL for? What should you use relational for? And the answer, I hate to be like, it depends. The vast majority of apps out there, aren't, um, Amazon or Facebook that need super fast databases, right? If you're a bank, you need to be super reliable. Some things that do transactions back and forth need to have fast connections. So it really depends on your app. There's MongoDB is a really good general purpose database, so you could use it for most of your apps probably. I want you to think about that when we look at the methodology. I'm actually going to go through like what queries were the most important. I think with any database, including relational, if you have a low number of writes and a high number of reads, that's a really super easy problem to scale as opposed to high writes and low reads, or even high writes and high reads. Although MongoDB does have native sharding, which makes that really easy. And Atlas also has a global clusters feature, which allows you to have clusters of your machines in different areas of the world, so that if you have users in Australia, they don't have to go all the way to San Francisco to a data center in San Francisco to get their information. They could get it nearer to them. So I hope that hasn't just brought up more questions. But ask it again when we finish like step 1 of the methodology, where we actually go through some of the queries, and we'll talk about reads versus writes there.
Yeah, I'll stop you if another question comes up.
Awesome. So this is a list of nationalities. Now, iPhone and Android give us this list in alphabetical order. And as you can see, Afghanistan is here. And if we wanted to find, Cuba, we can search for it. But United States is on top. And that's actually by design. A lot of the menus that you'll see in this application are settable on a per agency level, meaning that the name of the agency, right? The Ecuadorian Galapagos Navy, or the Coast Guard, if you're in the US, or whatever the name of the agency is. Wild Aid is an agency as well. They get to choose what shows up at the top here, right? So we have United States here, but because we're in the Galapagos, we could have done Ecuador and Panama at the top, because those might be the 2 most frequent ones. The people don't have to scroll down to get to the most common ones. But if I wanted to do Ecuador, I could put it here. We have a date selector here. Here's my date selector. Oops. A little buggy interfaces there. There we go. So if I want it to be yesterday or whatever, this is the date of the last delivery that was made. I can do that. There we go, September 10th. And where did they deliver it to? Like if they had fish and they wanted to drop it off at Legal Seafoods, they could do that. Electronic monitoring system is what's on the boat. And again, this is a menu that is settable per agency. And we can say, oh, there's there's a video monitoring system, and the registry number is 12345. We can add another one. So now, like, I don't know if you're thinking about the data model behind this now, but now you've got like this many-to-many relationship of vessels and electronic monitoring systems. We've also got this other item, and when you do this other item, you get a description of new monitoring system. And again, registry number would be 12345. So we're going to continue. We have some empty fields back there in last delivery. We left the business location blank. That's fine. Crew, again, here we've got crew members. We've got a captain. I can say the captain is Sheeri. We got a crew member of like Nick, and maybe we got a crew member of Karen too. Now, I don't know if you've noticed, but a lot of these fields have this little paperclip next to it. Even if we go here, this pencil is to edit something. We have a paperclip here. And what that is you can attach a photo or a note, right? And so I can attach a photo, which is what I wanted to do. And let's see if we go to the photo library. This is a simulator, so it doesn't quite have, photos of, boats or my cute kid or something. So here we go. It's a little slower.
I forgot from the previous stream. Is this a Swift application or is this a React Native application?
It's using Swift UI, I believe.
All right, I forgot. I couldn't remember. It's a sharp application.
So we have a node and our photo. Yeah, I'm like, it is a React application, but that's the website. It's node.js, right?
Well, no, so, React Native would be what a lot of people are using. I mean, it's all right.
Okay. I'm not a developer, by the way. I'm a product manager. Now you know.
With a lot of skill in
again, I don't want to
DBA.
spend too much time doing all this. Yeah, right. a lot of these fields have these paper clips. All of these are menus, right? So maybe we're like fishing and we're getting tuna and, we're getting tuna and nets. And all of these menus again are populated by agencies. So you might have this gear in this place, or in the Galapagos, you might have these fish, but by Papua New Guinea, you have different fish. So again, species, lots of species here. Menu, that's an edit menu. We've got things that we can add. We can add more catches here. So again, many to many here. Violations, right? So this is kind of the meat of the app, right? When we're talking about like how does this actually work to save the world, save our oceans, keep them clean. If you're doing something like illegal take and possession, right? So you get a warning. We're going to issue it to the captain, which is me. Let's say you had fish that were too small. You're not supposed to catch fish that are too small. You're supposed to let them grow big into the environment, and so that there are baby fish that grow into bigger fish. Otherwise, you can get into overfishing. So maybe they had some turtles that they're not allowed to have, and so maybe they seized the turtles, right? They can say seized, 5 turtles or something. And again, each violation depends on where you are because different countries have different laws. So let's go here. We can have a green risk. We can add some notes or photos or whatever. And finally we submit the app. We submit the boarding, and then we go here. And now, if we really want to, you could see this is our boarding that we just did. So that's just a brief overview of how that works. And now I wanted to do an even shorter overview of how the web works. So when we discussed with Wiley, like, what do they want? They were like, well, we want an app where officers can, just kind of like put stuff in and, it magically goes into a computer, because what they're using now is paper. So right now, somebody writes on a piece of paper. They don't write all those details. That would be like a book. And so that's part of the problem is they want more data than what they were getting, as opposed to just a violation issued. They want to get maybe some pictures. Maybe they also want to get like what gear was on the ship, because if they say that they're fishing but they don't have fishing gear, that's a little suspicious. Anyway, when we ask them like, okay, so now you're going to have this web interface, and the web interface is going to do some things. We can have charts, we can have maps, right? We can have how many hours did people work. But what's like your biggest metric? What's your biggest thing that you want to slice and dice your data? And they said compliance rate. We said, great, what's compliance rate? And they say the number of boardings that didn't have any violations or warnings, right? So you can see here we got about a quarter of the violations are compliant, and like 75% are not. And we were like, okay, what else? And they were like, compliance rate. And I was like, oh, well, but like, what about like, oh, well, this area had a lot of violations, so let's patrol more in that area. And they were like, well, we don't have that data from like the pieces of paper, right? They can't extract that data. They can say I have 10 pieces of paper and 3 of them had citations issued, 3 of them had violations. So that's a 70% compliance rate. So when they're moving from like paper to to a digital era, right, they're going to find that they have a lot more that they can get out of it. But right now they're like, we don't know. And that is actually a challenge when you're modeling data, because you don't know how people are going to use the app. You can guess, but you don't really know. And we expect that as the app gets used more, and as agencies are looking at the data, they're going to say, oh, you know what I really want to see is I really want to see it this way. And then, so we have this dashboard, but you can also look at boarding records. So here's all the boarding records. You can go in and look at a vessel. So here's all the vessel information. Oh, this is the boarding record. Sorry for this. If we wanted the vessel, we can go click here, and this is the vessel information for this vessel. So you can see it's got 1 permit number. It had a bunch of crew members, 4 different crew members. I don't know if you can see that very light 4 there. This vessel has had no violations. Let's go to a vessel that has had some violations. That would be more interesting. Let's go to vessels. Here, we'll go to something that had red. So we know they have at least 1 violation. And you can see here, yep, they had a violation here. Our test data of doing something else bad, you can see it was issued to this person. And yeah, like you can look at all the violations, right? There's a list of all the violations. So we can go to a crew member like Zeta Valentino, and now we get her listing. So this is all the vessels she's been on, and all the boardings that she's been a part of, and all the violations she's been a part of. She's been a part of 14 violations. We can see all of them. Anyway, so there's a bunch of, and there's a whole crew page too, which we were kind of clicking through some of this. Um, and besides that, there's users and agencies, right? So I'm a user. You can see I'm over here, SSCAP. And this is my user here. I'm part of the Ecuadorian Galapagos Agency. I could edit myself, and then there's a bunch of agencies. And with the agencies, what you can do is you can go to the Ecuadorian Galapagos, and you can see that form data. So you can see the fishing, transiting, and offloading we had, and you can see that here we've preferred the U.S. flag. This is a country code of things here. So you can see that this is where that those things from the menu are populated. So as we've done all that, I don't know if you were me. If you were me, you'd be like, okay, so now how do I model all that data? And when you model all that data, it gets a little complicated. So I wanted to show you a little bit of the document model and what things can look like in the document model. So here is just some data, right? We've got an agency, we call it Wild Aid. We've got a location, that's your latitude, longitude. We've got a vessel name and permit number. We've got a date. And this should look like the happy JSON that you are used to. When I talked about how MongoDB was different, I said that one of the things, so this is the JSON BSON. I said there was key value, right? So you have key value stores like here's an ID and here's the value of that ID. Here's the agency, here's the value, right? And I said it's not just strings, you've also got arrays and subdocuments, right? So here's an array, location, here's a couple different subdocuments. So you can see vessel is a subdocument. It's got some key value pairs in there. Reporting officer is a subdocument, and then name is a subdocument of that. So you can nest these things as far as you want. And when you're talking about polymorphism, I kind of explained it before in words, but now I can show you here. Let's say you just have this, this vessel name is Jenny and the home port is Boston. What if you didn't have the home port, but you did have a permit number? It can look like this. So in the relational model, you would end up having all these different kind of null tables and all that kind of stuff. So anyway, if you were me, you looked at all of that, and this is what you saw. This is overwhelming, but this is what it would look like in SQL. And I know because I took all the fields and I made this ER diagram. Now, what I've done here is I've highlighted the boarding records table. Hopefully you can see my cursor kind of circling the boarding
Yeah,
records table
the
here.
font
This
from
is
your slide is a
an
little
ER
small, but
diagram.
it's fine.
Okay, yeah, you don't need to really see all the names and everything, but all these blue links, there are 18 different tables. With this boarding records, there's 12 different tables that boarding records joins to. So that's 13 in total. So in order just to save all this information, you have to save it to 13 different places. There's 5 different many-to-many relationships, which are they're shown here because a lot of these are the menu data. So with the menu data, you have activities, right? That's all those activities of fishing and transiting and offloading were per agency. So every agency is going to have something different. And this is even a little simplified. Like I might put a position here to be like, well, the first one was fishing and the second one was transiting and the third one was offloading. They don't necessarily need to be in alphabetical order. And so this kind of gets, really tricky when you're like, okay, show me all the activities from the Wild Aid agency, right? Now you're thinking of all that SQL that you're writing, or maybe your ORM is writing. Here's your top countries. I did put a position there. That's that country picker, the preferred country. And now all of these tables are used in just one boarding record. This is a lot of joins. Now you saw that we divided things into pages like vessel name and vessel name and basic information and activity. And, most pages would kind of join 3 tables here. But that's still a lot of work. And so going through the methodology, let's go through what we would do to go through the methodology. So, oops, here we are with a spreadsheet. I love spreadsheets. And I wanted to get a little basic information about the data. Part of this is going to get to size, right? So here we are in 2020. This is the year 2020. And right now, Wild Aid is in about 50 marine protected areas. There's 1 or 2 agencies per marine protected area. They might be protected by more than one agency. So I just kind of put 75 in here. We couldn't get real hard numbers. When we did our data modeling, it's about 4 kilobytes per record, which includes things like officers and agency administrators. And we had about 750 records per day, right? If it's 10 per agency, instead of have agencies, you're talking about 10 per day. So we're talking about almost 3 megs a day, and per year, that's 1.04 gigabytes. So this is not a hugely fast growing application. This is not something that we would, for example, use sharding on, that it's going to be like hugely, the data set is just not going to be so huge, right? It could fit in memory. Now, again, this is per 1 year. Now, by 2025, if I can click over, there we go. This is their stretch goal. They want to be in 250 marine protected areas. So, now we're multiplying by 5, we have 375. And I'm putting a little bit of leeway here. I could have said 4 kilobytes per record, but let's be clear, right? In 5 years from now, the app's going to be a little different. It's probably going to store more information. So I'm putting 6 kilobytes per record. I'm trying to be, generous with my my calculations here, so I don't shoot myself in the foot. Because if I do capacity based on these calculations, I don't want to run out in 2 years instead of 5. So now we're talking 10 per agency, 3750. So now we're talking 22 megs a day, 7.8 gigs a year. That's probably more like, applications that folks are used to. So now let's talk about like peak times and average times. So a lot of people say things like, "Oh, my app is global and everyone's going to use it," and that's kind of difficult, because if you live in a certain place, right? You live in San Francisco, you're going to tell all your friends who live in San Francisco about your app, and they're going to use it, and it's going to naturally spread. Or if your application is in French and you live in Paris, right? You're not going to have necessarily a ton of um, I'm making this up, Mexican folks, right? Folks in Mexico using it, because it's kind of going to go out from your network and go from there. And so, a lot of times people are like, "Oh, it's global," but really think about where it is. So for this application, we're piloting it in the Galapagos and in Gabon. And so I just want to show you, oops, here is the Galapagos Islands over here, right? I'm over here in Boston. Nick, you're over here. You're
Somewhere in
off the map.
California.
Yeah. Galapagos Islands are over here, off the coast of Ecuador. And Gabon is over here on the east, kind of southernish coast of Africa. So, it actually looks like they're really far apart. They're only a couple hours difference, which is kind of weird. So Gabon, they're about 7 hours different. Gabon is UTC +1, Galapagos is UTC -6. Now, the writes are happening mostly on the mobile app, right? There are some writes if you're adding users or changing users or agencies in the web app, but on the mobile app is where most of the writes are happening. Well, those writes peak times are kind of in the daytime when boats are being boarded. There are boardings being done in the evenings and at night, but for the most part, they're during the day. So I just kind of have um, the other places where WildAid has marine presence are, let's see, from west to east, we've got the Galapagos, we've got the Bahamas over here. I think that's the right pin, the Bahamas. Aha. And you've got Gabon, and let's see, we've got Indonesia and the Palau Islands. So when you're looking at this, when we're going from, I can't even get them on the same screen. Well, I can get them on the same screen over here. From the Palau to the Galapagos, but the international date line's in the middle here. So from Palau to the Galapagos Islands, you're really getting almost, the entire world, right? They don't have a project right now in New Zealand, but they might at some point in the future. If they're going to get 250 marine protected areas, then they're probably going to have some there. And I put San Francisco's time zone in here, by the way, because that's where WildAid has their offices. So when we talk about peak times for reads, I'm going to talk about 9 to 5 p.m. local time, right? And so in the Galapagos, that's UTC 3 to 11. In Gabon, that's 10 to 18. And in Palau, that's, it's 6 p.m. to 2 a.m., right? 18 to 2. So we're really talking about from 3 a.m. to 2 a.m., which is good for a peak time when you're talking about, 4,000 records a day. Because when you're talking about 4,000 records a day spread over 20 hours, you don't need crazy hardware to keep up with that kind of queries.
So we
The
actually have a
average
question coming
reads
in the chat.
once.
And we may
Yeah,
want to hold off on this to fit with the flow.
sure.
So the question is from Menisk. Hello there, MongoDB. Are there any data model pattern for DWH analytics kind of workloads or reporting applications? Example, like a star schema with a periodic snapshot, so different periods, daily, weekly, etc., for easy and efficient reporting of business KPI dashboards.
The
That
answer
was a
is
lot.
yes. The answer is yes. And not going to answer that further because I'm going to talk about that more later, right? So the
Yeah.
third step was applying patterns. And because we don't have like, oh, here's a star schema or a snowflake schema, or here's, a relational model, we have patterns that you can apply. And so you'll see that later. But yes, and I'm so glad you asked that because that's such a great question. So yes, we do have that.
There was a
It's
part
just,
two.
again, not a mathematical formula like star or snowflake. Go ahead.
So part two was asked by another user, Geminisk, again, but to tack on to Menisk's question, I would like to hear Sheeri's opinion on the use of views as she would in a relational database world.
Oh, materialized or virtual?
That wasn't listed in the question, but we can wait for a response and see what happens. So material or
Sure.
virtual?
Yeah.
It was material or virtual? Is that what you said?
Materialized or virtual views. Yeah.
Yeah, let me just
So a
type it.
virtual view is basically like a query that just makes a new kind of, it's like a projection of the data. Um, and a materialized view is when you kind of take that projection and kind of save it to disk. So you're actually doing that.
Yeah.
Um,
And I
so
don't
yeah,
know if
my
my
opinions are that
oh, go on.
yeah, don't worry about it. My opinions are that materialized views and virtual views have their place. For example, using a virtual view or just a view, usually they're just called views and materialized views. So using a view on, and I don't know if you're talking about like a table or a collection. On a collection, we can do projections. A lot of time those are used, those don't have a lot of space overhead, but they have to recalculate every time because it's a virtual thing that you recalculate it. A lot of times those can be useful for security purposes. For example, you have this data in a table, let's say, or in a document. You don't want people to see sensitive information, so you don't give them the access to see those columns, for example. And so maybe you have a view that will show them that, as opposed to trying to deal with like column level access. So you give them access to the view, but not the underlying table or something like that. Materialized views can be super useful when you're doing calculations on things because you calculate something and then you store it. One of our patterns is a calculation, so we will talk about that. Although I don't have an example of that.
Yeah.
One of the things, if you like to hear me talk, but you like to Google search while you hear me talk, if you look up MongoDB patterns, um, there's an awesome blog post about 12 different patterns that we have, and computed is one of those patterns that you would use.
Is this the one by
The
Lauren?
pattern that I would use is the one by Lauren. I believe Daniel Kupal
All right.
co-edited it. It is uh, it's the blog post where it goes through all the patterns. I know that's terrible, right?
Yeah.
MongoDB schema
I
patterns.
think Lauren was going to come on a stream in 2 weeks to talk about that stuff.
Sweet. I'll get that URL
Yeah.
later.
And
So,
in regards to the
yeah, so here we're
follow-ups
talking
regarding
about.
the views,
Oh, go ahead.
both of them were interested in the materialized version.
Oh, in materialized versions. Yeah, I mean, you're
Yeah.
doing a bunch of calculations to store the data. And so it can be useful to do. Some different database systems have optimized and materialized views more than others. In some database systems, you're just basically like doing a write, or it's, you might as well just do like a trigger on a table that does a write, and, that'll write to another table and do a calculation. But again, they do have their purposes. I don't tend to use them that much. So I guess that's my opinion. Like, not that they're terrible, I just don't use them that much. So, uh, anything else?
Perfect. No, I think that's it for now. I'll stop you if something comes up.
Great. And the the blog series I was thinking about is called Building with Patterns. There's a summary post, and it's by Daniel Kupal and Ken Alger.
Ah, got it.
So Building with Patterns. That's the magic search phrase, Building with Patterns, MongoDB. So we were here talking about peak times, right? That this is kind of truly global. If you are a coffee shop, for example, you're going to have that peak time before work, after work, where people are running to get their coffee, maybe lunchtime, maybe on a Saturday or Sunday morning, people are getting their coffee and their donuts and their bagels. Um, and then if you open another store, you might have some more peak times but it's the same peak time because you're probably opening a store like, a town or two away. You're not necessarily opening another time zone. But then, if you're, a huge multinational coffee chain, you have peak times everywhere. But even when you have peak times everywhere, you have bigger peaks in certain places, right? In the US, Starbucks has a ton of coffee shops and they have coffee shops all over the world, but they sell more coffee in the States, right? So they're going to have more reads and writes there if they have a database doing their coffee things. So this is our app. So the peak time reads, again, we're doing that. Average reads, we got agency administrators, Monday morning getting their report on what happened last week. Wild Aid might do it every day, do some reports, or if they're researching stuff. And so, I just put this here. This is 10 to 11 a.m. here. This is 3 to 4. But again, it's not adding much. It's just not really changing this whole, UTC 3 a.m. to 2 a.m. time frame. So now I'm going to kind of list out the queries. When I said list out the queries, Nick, this was your great question. This is what I meant, right? So we have boarding report writes. Now I'm not writing a query here. I'm just writing like this is what we're doing. This is the most frequent query that's going to happen because every time there's a boarding record, it writes. Now a lot of applications are more reads than writes, right? If you have a shopping application, more people are viewing a product, right? They might view 3 or 4 products, but only buy one. A banking application, you might transfer money, but you probably view your balance a lot more often than you transfer money or make a payment. So it really, again, depends on what you're doing. In our case, it doesn't necessarily matter because it's just such a low frequency of writes. And obviously, we hope it's going to be huge and explode. But when you're thinking about your data model, you do want to think about the usage that you're getting. And it's an interesting trap to get into to think about like, well, what about in the future? And it's like, well, you don't know how people are going to use it in the future. So people like to future proof things, and I found that even in like the SQL world, you end up getting like, well, we might have a field that we want to add, so let's just add a new field and call it like new one and new two, so we don't have to alter the table later. And I've come to organizations that have a new one and a new two, and I'm like, what's that? And they were like, well, that's in case we need to add a table. I'm like, well, then why are you doing this migration or just in case we need to add a field to this big table? I'm like, well, then why are you doing a migration to add a field to the new table? Like, well, but we wanted it to have this name. It's like, well, you're not even using this future proofing that you were doing. So, we all do funny things sometimes. There's reads for the Realm Sync Mobile. You saw that when I was using the application, there were already boarding records in there for the vessels. I could choose a vessel. So we're actually doing reads and writes back and forth with Realm Sync. We have boardings by agency. That was when we had this page here, the dashboard here. It's per agency, right? So I was getting the Ecuadorian Galapagos agency reads there. I was getting those boardings. Boardings by reporting officer. If an officer logs in, they'll see their own boardings. We could see, all boardings if we go here, right? So here we're seeing all the boardings, and all the vessels and all the crew, and of course all the individual records. So all boardings, boarding record, all vessels, vessels information, all crew, all captain, crew captain, and we have ad hoc filtered queries. So one of the interesting things here, or here, we have all these boarding records, but now we can do some filters. So let's say I want to filter on a red risk. Now I've filtered on all this stuff. And by the way, this internally is using full text search. So if you were going to search something here, it's using full text search with facets. And the filters are these facets that you can do. So you can see that all of these red um, red boarding records is where we filtered on red. So we have these ad hoc filtered queries because we have a filter on everything. It could be date, it could be the vessel name, it could be whatever. So I put that in there because that's going to happen a lot, especially at first. And so this is how we're expecting people to use the app as we design this schema. I can imagine that maybe they're going to want to look at a specific vessel, or maybe they're going to look at a specific species of fish and see, like, okay, does this have problems, or are there a lot of violations somewhere in the world? But that's not what they told us that they wanted to do. So for now, we're keeping it to what they wanted to. And then we've got the user and agency changes, which again are going to happen infrequently. So now that we've done this, we kind of want to do this quantitative, qualitative analysis of what these are. So these boarding report writes, again, 750 a day. We're going to have to multiply by 5 for 2025. But when I divided this out by a 20-hour window, I know it's really a 23-hour window, but I did some hand wavy math. It's about 37.5 an hour, right? So we're talking about one every other minute. And when you multiply by 5, you're still talking about like a couple per minute. So we're not in the 1,000 queries a second here. MongoDB can certainly handle that. This is just not the app that I have, that I helped work on. It's not the app that I product manage, so that's what we have. But the criticality of the writes are high, and so I'm putting a speed here. Like, this is what we want. We want the writes to complete within 100 milliseconds. But in the notes here I have here, I wrote that it would peak is based on a 20-hour window. That Realm Sync is doing this work for us, so it doesn't actually matter how fast the writes happen because it comes back right away. When we submitted the boarding, it came back right away, and then Realm Sync is handling in the background what's happening. So this kind of speed requirement kind of goes away. Similarly, with the Realm Sync mobile, the average frequency is variable. How often is it reading new records? Well, how often do new records come in, and how often are they within range of cell or Wi-Fi or something? There's really not a peak frequency, and that's kind of a medium criticality. If they don't get the freshest records, it's not the end of the world. Again, they want it to be pretty fast, and that's handled by Realm Sync. Boardings by agency, the criticality is high. They want like a 2-second. Using a web app, it doesn't have to be the fastest thing, right? These are people who are using like slow computers. This isn't like a tech agency or like someone with their new Samsung Galaxy Fold device. Is getting the expensive equipment, right? These are not-for-profit organizations or governmental organizations, and some of them may have low-speed internet. So I just kind of like filled the rest of this out. I used a red for high and medium, right? So we've got some boardings by reporting officers low because, who cares if the officers themselves need to take a while to see their records, right? Just if it takes a while for the page to load. All boarding records. Again, these folks are dealing with a paper to digital infrastructure. So I'm being realistic about this. This isn't what the customer gave me. They didn't say, oh, I need to be less than 2 seconds, because they're always going to say everything has to be fast. And if everything's fast, then guess what? Nothing is going to be fast. So now that we've done that, I want to show you in Visual Studio what kinds of schemas you can make. So here's a schema based on the boarding record, right? And you saw some of this in the example before. So we've got an ID, we've got a date, the date of the boarding. Here's the location. We have a reporting officer, right? This was the person who boarded the boat and their agency. We've got a captain of the boat, a crew member of the boat. We've got an inspection that they did, right? So here's the activity, the fishery, the gear type, what they actually caught. You can see this is an array. Even though there's only one item in it, there could be more than one item in it. You've got a summary. This is the green, yellow, red. Did they seize anything? Were there any violations going on? And here's some data about the vessel, the name. There was a photo for this vessel. The home port was London. The nationality was the UK. Here was the last delivery. So we've got all this information in one document. Now remember, this is the equivalent of a row in a relational database, but this has so much more information than one of those, right, rows in one of those tables, right? This kind of groups together a whole lot of tables. Now, I chose boarding record to group on. We could choose something like vessel, and this is where that star schema, snowflake schema gets into what we're doing here, right? So here I'm doing by vessel. So this is the ID of the vessel. This is the name of the vessel, right? Here's the photo. So I just took the same information that was in the boarding record and I put it here. And now what we have here, this is a new field called boarding. And what I did here is we have a boarding. So here we have boarding on this date, and then I put all this information here, so this is actually one document. Here we go. From here all the way to here, this is the boarding document for the boarding that we did. But you could see the vessel number, the photos, the home port. Like this is all, this doesn't change. So you don't need to have one document per boarding. You could actually merge them together based on the vessel, right? Um, and here you have the second boarding record, right? Like this boarding record was on 7:30. Maybe there was one on September 1st. Maybe there was another one, and you could keep going. And here you have this array, and you can keep going and going and going. Now, um, this is certainly valid for a use case. What use case is it valid for? I would do this if you're getting the vessel information a lot. If we know that we're getting, we're reading that vessel page that showed all the vessel information a lot, we might want to do that. We could even do something like risk, right? This would be very silly. But imagine that you had all of this information in the boarding record except for, green, yellow, red, and then you just had a risk red, and then you had all the boarding record and all the information here, right? Every single one of those records, right? But this is kind of where you can kind of slice on those facts and dimensions, right? Is that you can kind of say, okay, if I want a dimension, of kind of like risk, then here's my dimension, and then here's kind of like my facts inside. It's a weird, it's not really an exact analogy to a star schema like that. But this is where MongoDB has the power, because you can, when I this based on vessel, we took all the vessel information, we put it in one place, and this may or may not change based on the boarding, right? Like the permit number is not going to change, where it's registered to isn't going to change. At last delivery, we should probably put that in the boarding. That'll probably change. And photos might be added to. We could have just a whole array of photos. Um, in London as the home port. Again, not going to change so much. The name is going to change. So, you know, if you do this, you have to make sure that whatever your parent object is, right here, the parent object is vessel. You have to make sure that that is mandatory, right? Like we couldn't do it on something like, let's see, violation. Violation couldn't be the top here if we were embedding everything, because violation is not necessarily going to be there. So we can't just have a vessel with no violation. You can't have a child without a parent when you're embedding things. So how do you choose whether to embed something or link something? When I do it, I know a lot of people kind of start with this. Let's go back to this PowerPoint, um, this model here, right? They start with this and they're like, okay, what can I combine? But I like to start with the whole thing and try to see like where does it make sense. And for me, where it often makes sense is how the app thinks about it, which is super interesting because we kind of have two apps here, right? We actually have three because we've got a mobile, we've got iOS and Android, but you've got the mobile app for kind of writing with these boarding records, and then you've got the reads, which kind of just do everything. So I chose the boarding record itself to be kind of the main one. I say I chose it, but I'm not even the one who designed the schema. I did look it over. Our lead developer, Andrew Morgan, did, and he did a great job. And so we did it he did it based on boarding records, and I liked it. And I said, yeah, that's good. Let's do it. And so, we do have kind of arrays of things, right? We have an array of violations, we have arrays of catches, but this isn't kind of doing that. I'll call it a bucket. If you had, for example, sensor data, you might have information about the sensor, right? Like it'll have an ID, and maybe it has a position somewhere. Maybe it has, information about, I don't know, when it was last updated, right? This stuff is not going to change. But if the sensor is outputting data once a second or once a minute, instead of making one row every minute, you could do something more like this, where instead of a big boarding record, what this is, oh, this is the temperature. This is the temperature, right? Like this is the temperature, maybe this is, it could be something like temperature readings, and maybe you'd have something like, 97.1, and then it would be, the date and time. Or this is where it gets really funky, is you could do something like temp hour 3. Let's say the 3 a.m. hour. And then you could have something that's like, well, the temperature is 97.1 and the minute is 07 or 02. And every minute it, spits out something else. Or you could say, the time is, 3:02 and 4 seconds. And so you can kind of aggregate all this information instead of having all of the metadata about the information in each row, in each record. You could have it kind of starting to be ready to aggregate here. Or you could do the calculations yourself and aggregate them. So hopefully that helps with that data warehousing question. Let me know.
Yeah, I'll bring it up if we get follow up.
Great, great. And so now I want to do this big reveal of what we did. So we're here on step 2 where we're modeling the relationships. Oh, I want to say modeling the relationships. So we've got all these crazy things where, we have these many-to-many relationships, like with violations, right? You have many-to-many relationship with violations. And you have this, not only does, you can have many violations per boarding, but the violation is also associated with a crew. And there can also be many crew per boarding. So you've got all these kind of, join tables, as I used to call them. And it just makes this so complex. So if we look at this, let's look at users first. Here, this is a lot simpler. This is kind of the collection relationship diagram, if you will. So you've got an agency here, right? If we have a user, right? You've got an agency which has a name, and that shouldn't say, an admin is a Boolean flag. That's whether or not they're an administrator of the agency, right? So the head of the agency gets that, but a field officer wouldn't necessarily be an agency administrator. And then you have a name, a first name, a last name, probably an email address, and then whether or not they're a global administrator for the whole thing, right? That means they could add an agency, right? Whereas an agency administrator could add a user. But a user, regular field officer can't add anything. They can just, change their password. So here I've been trying to be kind of honest about the, I won't say honest, but like I've been explicit about putting all these here. Like agency is a document, but it contains this varchar and this Boolean. Whereas, if you look at boarding records, for example, you have something like inspection or vessel, and I didn't put all the fields there because it would get like huge. But it's still honest because here we actually only have 4 collections in our schema. Oops, there we go. So, you could see here that what we've done with this menu data collection is we have all these arrays. And so now all of these things that were, my mouse is glitching a little bit, all of these things that were different tables, gear, fisheries, the top countries, the species, the EMS types, the activities, all that stuff is now in one table, right? The EMS types, the country preference. And so it does actually go back to the agencies, but the agency now only has a couple of links to things, right? It links to users, menu data, and boarding records. It doesn't link to all of these, 7 tables or whatever it is. I think it's actually 8. And so this kind of gets a lot simpler when you're talking about like, oh, am I going to have to now look something up from a different collection? The fastest lookup is no lookup. Just like in SQL, the fastest join is no join. And that's why we denormalize for speed. So using kind of embedded information like documents and arrays is a way to really speed that up and put all that information in one collection in MongoDB. So there are still kind of lots of references from boarding records. You can see that this inspection, right, is going to be connected to all of the stuff. It's going to be, connected to the activities and the fisheries and whatever. But what happens is somebody logs into the mobile app and they get all this menu data in an array and it gets used. And when they store it in the document for the inspection, it's just stored as text, right, which you saw over here, right? This literally is how it is. I copied and pasted this from our database with mock data. You could see with Forrest Gump. And it's, the name is phishing. This isn't, a link to another collection. This isn't something that's like, oh, it's, the Wild Aid Agency's second activity on the list. It's just phishing. And part of this is that if those activities ever change, we don't want this record to change. We want this record to say like it was phishing. That's what it was doing. So even if they reorder it and phishing is first instead of second, that's going to stay true on this document. So I know we're getting close on time. So I just want to say it's a methodology, not a formula. So you evaluate the application workload. That was step 1. What I didn't talk about is the patterns. So let's talk about the patterns really quickly. When I talked about applying patterns, I've talked about computing a little bit. One of the things that we talk about is a reference pattern, right? So this is a reference pattern here because I'm referring to something in another table. Reporting officer is actually a really good reference, right? This is actually an extended reference because I'm not just using the email, which is the kind of primary key we have there, but I'm also giving the name. And this is so that when we don't have to do a lookup to find the first and last name. It's just right there. And yes, that duplicates information, but storage is a whole lot cheaper these days. And I would rather use a little more storage when you're not using more memory because you're not joining those tables, you're not looking them up, than have to do stuff. Um, and basically, indexes here are just faster than joins. So if you want to look up all of the vessels, how do we get all the vessels? We look at all the boarding records and we have an index on vessel.name and also the permit number. We make it unique by name and permit number, not just name. And so that's just a whole lot faster than trying to, find all the vessels. And because if you just had a vessels table, that would be super fast. Find me all the vessels. But when you're getting to, oh, my pointer is getting away from me. Here we go. When you get to something like this page, it's not just getting the vessel name and the permit number, right? It's getting when it was last boarded, right? So here, if this were SQL, you'd have to join to find when was the most recent boarding record and what was its risk level, red or amber or green. So even on this page, right, we would have to do joins, right? There's no page in which we wouldn't have to do a join in an SQL system. Whereas, you go here and obviously, oops, I don't want to do that one. I want to do this one. And you saw how that fast that was. Even though we've, looked up however many records, right? There's 31 captains, there's 35 different boardings. It was super fast because there's an index on the vessel and permit number. And so it's just easy to get all that data from there. And you didn't have to do 70,000 joins to get all this data. So I talked about reference pattern, extended reference pattern. One of the things about MongoDB that's pretty cool is because these are just, fields and whatever, you can do a calculation. So the cool part about this is an update to a document, right? If you're inserting or updating a document, you can update any of this information and it's all atomic within that one write because this is the equivalent of a row in SQL, right? If you update two different columns in the same row, it's atomic. It's the same thing with MongoDB. It's just that you have way more information in the row equivalent, which is called a document. So let's see. And by the way, I talked about 4 different patterns computed, right? So you can compute a value, you can compute a sum or an average. Like if you had rankings, for example, you might end up storing something. You might have the ranking itself, and then in a vessel, like if you had something like rankings, you might actually have a need to separate out, the vessels or whatever the object was being ranked. And then you might have a field here that was something like, rank count, right, which is the number of people who ranked it, and rank total. And for easy math, we could say 99. And for rank total, you can say something like, oh, it's 9900, or let's say 990. It's got 10 out of 10s for everything. And when you then inserted a new boarding, you would update the boarding and you would push a new boarding to the end, and then you would add, say, the rank here. So it was, user number 100, and they didn't like it so much they give it a 5. And so then you can have the rank, right, which is just calculated by, this would be 9.95 at this point. Although these are numbers, you don't need to use quotes. So that being said, it's, we say it's as easy as 1, 2, 3, but it's a lot of work. You evaluate your application workload. How do you do that? Business domain expertise. So that's when we were talking to the people about like, how do you use your app? Current and predicted scenarios. And again, you don't want to think too much in the future, but you think, a couple months in the future, how are you going to do it? Because you can always change that, right? What are the things that you might say is, well, why didn't you take out the vessels from here? Like that seems like something, where the captain of the crew. And my answer is we don't need to right now. And I don't necessarily know that that's what they're going to be searching on. They might be searching on something like violations, right? We might have to take apart inspection to get those violations inside that inspection. Or maybe they're going to be looking at things that are red, or maybe they're looking at species. We don't know what the most popular queries are going to be. So until we do, I don't want to make any assumptions, because if we do, it's just going to end up looking like this. And that's not going to be optimal because it takes longer to look up things in 13 different collections. So production logs and stats, if you have a current, application, you can look at what literally are the most frequent queries or the longest running queries that you want to get shorter. Again, data size. And data size kind of speaks to, do you need to shard your data, put it on multiple nodes? How much memory do you have? Can it all fit in memory? And a list of operations ranked by importance, right? Which we had in that spreadsheet. And so this is kind of the output that you're getting. Then you do the map. Again, some people like to start with kind of thinking of the objects and smushing them together. I like to start with everything together and then take it out. So, for example, when I did this and I had everything in boarding records, including agencies, including users, I didn't know what to do with menu data. I didn't really know how to do that within boarding records. Like, how do you show? It really was connected to agency only, and it only was used to fill in something in boarding record. So all this menu data, like, that was the first thing naturally that I was like, oh, this should come out. And then users and agencies kind of followed, mostly because of permissions and having to log in. So one of the other things we're using is Realm to log in to the application. So the database isn't storing passwords, Realm is, and that is awesome. And I don't remember if we talked about that on our Twitch stream earlier, but the one that I did with Karen in July. But it is using Realm for that, which is kind of awesome because you can have all of your permissions in one place and different. We have an iOS and an Android and mobile application. They can all use Realm, and you don't have to worry about it being in your database with your data.
So we have a
So map
question
out
coming in
menus
the
in a
chat.
relationship.
So the
Yeah.
question is, what tools are you using for creating MongoDB data models? Are there any free or open source tools?
I use terminal window. um, there are some great tools actually for it. I like MongoDB Compass. So one of the cool things about MongoDB Compass, that it has built in is it has a. So here's the thing: MongoDB doesn't have a schema until you put data in it. You can't just like create a collection and say, oh, it's going to have a name and it's going to have attachments. You can actually do something called schema validation, which says, yeah, everything should have a name and it should be text, or you could say everything should be, there should be a rank and it should be below 10. And there's a lot of different ways that you can validate your schema, but um, there's no place to formally write in like this is your schema. Um, Other than that kind of like validation. So let's say I'm going to go here. This is actually the data that I was using there. And you can see we have this wild ape database. And one of the things that I love about this is, where did my
Can you
stuff
zoom in,
go?
like Control Plus or
Can I
Command
zoom in?
Plus?
I sure
Perfect.
can.
Thank you. Just
Where
make that
did
thing
my,
full screen.
oh yeah, where did my schema analyzer go though? It should be here at the top. I think I've hidden part of the Compass thing. You know what I'm talking about, right, Nick?
The Schema Analyzer?
Oh, you know why?
Uh,
No, yeah, Schema Analyzer.
wrong
Sorry, I
tab,
had to
right?
go. I'm in a database. Then I had to go to a collection. That's why.
Yeah.
So this is a collection of data, and you can see none of this is secure data because it's made up data. But you can see, like, here's the time. Like, this is literally what our boarding records look like. I was not lying to you. So you can actually go to the schema, and there's this little tool called Analyze Schema, and you can see that there's 3,100 documents, and they sampled 1,000, and you can see that. Let's see, this is cool. Actually, I like this. There's some arrays and some documents. We actually had an older style where we did a document of crew, but then we moved it to an array. So, it's a document of arrays, an array of documents. You can see there's a 2% are undefined of crew. So it gives you this little histogram of things on the side here too. So here you've got date, how many were on Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, right? Like, that's pretty cool. And this is just analyzing all the data in there. But it does manage to give you some good insight. And so for me, that helps me figure out kind of what my schema should be sometimes. Because if here, like with notes, sometimes it's an array and sometimes it's a string. And so when you are saying like, hey, what should I do with this? Sometimes you can like put in the data that you have, or you're thinking about it and seeing how it looks. Like if we go to user data and we analyze the schema, and this, by the way, is free. Compass is a free GUI tool. You can also do some aggregations and documents, get explain pan, show the indexes, do your schema validation. You can do it all in this. And this is actually a really awesome tool that I love. And you can see here with the user active flag, there are 100% of the things that have a Boolean value which is 95% of data, are true. Nobody is false, but there are some undefines, right? And remember what I said is that with MongoDB, you don't have to have a key value pair for everything. This is also interesting. I don't know what this is. I think we use this for something and then stopped because you can see that there's 20% of the data has it, 80% doesn't. Does that help answer the question? There's nothing that will tell you how great your schema is because it depends on your usage. So you really have to kind of do that yourself and test that yourself to see if one schema would be faster than another for the queries that you have.
No follow-up on that one yet. We are getting a suggestion to do a part 2 to data modeling. So to go into more depth on some of the patterns and then even explore data validation.
I am so glad that you asked that because I don't have a step 2, but I do have a lot of things here that you can look at. So there were some really great MongoDB.live conference talks back in June, but if you missed it, that's fine. You can find them online. I think you can either find them on YouTube or on our website. You can find data modeling with MongoDB. And advanced schema design patterns was another great one. So you might want to look at that one, and a complete methodology of data modeling. Those are some really great ones. There are some great blog posts. Like we said, building with patterns is a great summary. There's like a dozen different they have one article for every pattern. And so that really goes in depth, and that's fantastic. MongoDB University is free, high quality courses that teach you these things. And when I say they're high quality, I mean, when I came to MongoDB, I didn't, I knew MongoDB was a document database, but I didn't know any of this modeling stuff. I had 18 years of, schema design with relational databases. And there's a course, it's called the number is 320, MongoDB University 320, and it's called data modeling, and it's free. And that's how I learned data modeling. So, the tools that I used internally, like this is what we give our employees to train on. That's what you get too. It's fantastic and it's free. Love free. And there's also, we have a developer portal, developer hub at developer.mongodb.com where you can ask your questions. Developer forum. Let me show you what that looks like in the website. Developer.mongodb.com. And here we are. So you can find links to articles and things in here. You can also, I have lost my pointer again. You can see we're doing a Twitch stream right now, live. You can go to the community tab up here, and this is forums. So for example, we have forums for Realm and charts and Atlas, and we have even one for open source projects. So if you wanted to go to...
Can you zoom in a little bit since you're doing some navigation in
yeah.
there? Sweet.
Yeah, and what would be fantastic is if I could see my mouse pointer. Oh, there I am. Let me go down. I can't actually see my mouse pointer, so I don't know where I'm. There we go. So we can go to categories. Oh, I should probably log in to see posts. At any rate, I'm sorry, I can't actually see my mouse, so I'm kind of a little stymied here too.
It's all good. We see it, but you know what? Sometimes it spazzes out.
Yeah, there we go. So here's a post. I just clicked on a random post. So the posts are on the right side here, right? So we can see, for example, the code of conduct. There we go. So you can see the code of conduct. Here's an example of a post. This one probably doesn't have a. You probably can't comment on the code of conduct. Oh, you can. You can reply if you want. So yeah, it's just a forum. Oh, I found my mouse. Just a forum. That you can, now I have to log in. So anyway, developer.mongodb.com, and you can have conversations with folks in the community forums. Great. Anything
Awesome.
I didn't answer?
No, I think that was good. I think you covered quite a bit of ground, and this was actually a good follow-up to the previous Wild Aid stream that you did in July. So this could be considered a part 2 in sense.
Sure, but I hope it's stood alone. That's why I did the demo at the outset, so that people, you didn't have to watch the first one to watch this one.
Absolutely. Yes, I mean, we'll give it a second for any other last minute questions to trickle in. But as far as plugs go, sign up for that community forum. So community.mongodb.com. Uh, Cruise around for any kind of questions that might exist. Also, feel free to publish questions. I hang out in the community forums. I'm sure Sheeri does as well. Um,
Hmm.
and when it comes to data modeling, it's Sheeri did a great job at this, and I think it does deserve maybe a follow up, like the suggestion had been given on validation. What do you think?
Yeah, it's a really tough topic, especially if you have if you're in a relational mindset. But even if you're not in a relational mindset, it's hard because there's no one magic way to be like, oh, I'm done. And I mean, my opinion is that even if you have normalization, there's still no way to say I'm done because you denormalize based on your usage.
Yeah,
And so, with MongoDB, it's just like we're not trying to pretend that there's a formula, then you're going to denormalize anyway. We start off with, you're just um, you're getting there and you're thinking about what you're using first, right? Not just kind of going through an exercise to make something and then thinking about your usage and denormalizing. So
yeah,
yeah.
awesome. So it doesn't look like there's any more questions. So unless you have a last minute plug that you want to give out, I think we call it a day on the stream. On a happy Friday, everyone.
Yeah, happy Friday. Thanks for joining me so much. I really appreciate it. I don't like talking to myself. So
That was
I
good.
do like talking to Nick, and we could have just chatted back and forth.
All right.
And thank you, by the way, to Nick and Karen and Yulia and Danielle, who all helped me with this presentation, and I learned so much. Yulia actually is the one who does the modeling course on University, and Danielle is one of the authors of that blog post, the Building with Patterns series of blog posts, as
Yep.
well as some of the videos that I think he did the complete methodology of data modeling, and I think he did advanced schema design patterns with somebody else too.
Yeah. And
And
Yulia
Yulia
was
did
actually
data
on the
modeling.
podcast.
Yeah, she was talking about data modeling.
Yeah, on
So
the
that's another
podcast.
plug. There is a podcast. So
Mongodb podcast.
that,
Look it up on
yeah,
Apple Podcasts or Spotify or wherever you listen to podcasts.
that's right. That's
All
right.
right, sounds good, everyone.
Great.
Catch you next time.